Hello everyone, welcome to today's lecture. In our today's lecture, we are going to learn about Bayesian classification by Navy-Bayes classifier. So Navy-Bayes classifier is a method used for the classification. So let's understand it with one example. So this is the data set that is given in the question. So the data set contain the attributes like color, type, origin. Yes, and this last attribute, which is a stolen. So this is a class variable, as we already discussed in the decision tree. So this is a class attribute. Now this attribute is a classifier attribute. So the answer, the label of the classification is only in yes and no here. Yes, so these are the labels of these data sets. So here the data set is of car data set. So cars. So it contains values like color of the car, type of the car, origin, and if it is given that if color of the car is red, type is a sports, and origin is domestic, then it is a possibility of stolen. So the label is yes. So this data set is already given. We already discussed that in the classification, the training data set is already given, and we have to find the value for the test data set. So this training data set is already given. Now this sample is a test sample. So in the test sample, now we want to classify that if color is red, type is SUV, and origin is domestic, then what is the possibility of stolen? So this is a test set. So based on this data set, we have to find that if these are the features, then it is stolen or not. So this the test set is not in the training data set. So this is a training data set. So as we know that color is red, SUV in domestic. So red, so all cars is sports. In this red, one is SUV, but origin is imported, not domestic. Yes. So this data is not in the training data set, and this unseen sample is given as a test. And now by using the Navy-Bayes classifier, we'll discuss that how we can find the possibility of stolen or not. So let's start. So first, the Navy-Bayes classifier is based on the probability. The probability that we already learned in our 10th class or 11th classes. So the probability now we'll use in this example. So first step is find the probability of yes and no for the whole table. Yes, the stolen is a class variable. So now we'll find that what is the probability of car is stolen or not. So for that, total number of data set is 10. Yes. So divide by data set is 10. Yes. Now what is the probability of yes from this whole data set? From this 10 data set, what is the possibility of yes? So now we can see that this is one yes, this is a second, this is a third, this is a fourth, and this is a 5. So there are 5 data set, and in which the possibility of stolen is yes. So we'll write 5 here. Same, the probability of no. So from whole data set, the number of data set is 10. So from 10 data set, what is the possibility of, or what is the probability of no? So here for no, this is a 1, 2, 3, 4, and 5. Yes, the probability of no is also 5 divided by 10. So now this is the first step. You need to find the probability of yes or no from whole data set. So this is the first step. Now the second step is, for each of these attribute, color, type, and origin, for each of the attribute we need to find the probability. Yes, so let's understand with the first attribute, which is a color. So now this is one table, and in this we'll find the probability of the color red in yes and the color yellow in yes. Also same as a color red and no, and yellow and no. Yes, start with the first. So what is the probability of car that is stolen and the color is red? Yes, so now let's start. Same again, now we know that probability of yes is 5, that we already calculated that probability of 5 is sorry, probability of yes is 5. So 5 times yes in this data set. So here the probability of yes is 5. Yes, and in yes, how many car is there whose color is red? So now let's start. Here the probability yes and color is red. Second probability yes, color is red. Third yes, probability is yes, color is yellow. Yes, probability color is yellow, and yes, color is red. So here there are 3 cases where the probability of stolen is yes and color is red. So it becomes 3 by 5. Same as probability of stolen is no and color is red. So here probability of stolen is no here and color is red. That is 1. No and yellow. No and yellow. No and yellow, no and yellow, no and red. So there are 2 possibility where stolen is no and color is red. So here for no, the number of no's, a probability of no is 5. There are 5 data sample in which stolen is no. So in 5, how many car is there whose color is red? So there is only a 2 car whose color is red. Now same as for yellow, we'll find, so we'll put 5 here. Yes, same as in this table also. For yes, we'll write 5. Okay. Now next is if probability is of stolen is yes and the color is yellow. So here the probability is yes and color is red. So now from that, probability is yes, color is yellow. Probability of yes, color is yellow. So there is 2 possibility where color is yellow and stolen is yes. Same as in this no, there are possibility of stolen is no, color is yellow, no, color is yellow, and sorry, this no, color is yellow, no, color is yellow, and this no and color is yellow. So there is 3 data sets where stolen is no and color is yellow. So this is how the first table is calculated. Same as in the type. Now we'll calculate that. What is the probability where stolen is yes and type is SUV? So stolen is yes, type is SUV. Sports, yes, sports, here yes, SUV, yes, in this yes, SUV, and this yes. There is only a 1 data set here in which the stolen is yes and type is SUV, so 1 by 5. Same is the probability of SUV where probability of stolen is no and type is SUV. So here for no, no SUV, no SUV, no SUV. So there is only a 3 data sample in which the probability of stolen is no and type is SUV. Same as in the sports, what is the probability where stolen is yes and type is sports? So there are 4 data samples, and what is the probability of stolen is no and type is sports? So here no, that is 1, no, 2. So there is 2 data sample for in which the probability of stolen is no and the type is SU. Same as in third origin, the probability of stolen is yes and domestic, and origin is domestic. So here in yes, domestic is origin is domestic. Yes, origin is domestic. Yes, imported. Yes, imported. Yes, so there is 2 data sample here, and in same as in no. So for no domestic, yes, and no domestic. So there are 3 data samples here. Same as in this where probability of stolen is yes and the origin is imported. So there are 3 data samples here, and now where probability of stolen is no and origin is imported. So there is 2 data sample here. So I think in this imported, yes 1, yes 1 and yes 1 3. So that's it. This is how we can create this 3 probability table of each attribute. Now the last step is, now we already given that this is a test sample where color is red, type is SUV, and origin is domestic. If it is this is already given in the question, but if it is not, then you can choose by yourself, but make sure that the selected sample does not repeated in the training set. So now let's start with this. So this is a sample that this is a sample data set, test data set. Now we have to find that if these are the attributes, then the car is stolen or not. So for that, the equation is probability of sample X divided by yes into probability of yes. So now it become probability of X means the first sample red, so red divided by yes into probability of SUV divided by yes into probability of domestic divided by yes. So into probability of yes. So now is equals to probability of red, probability of yes, probability of stolen is yes and the color is red, that we already find that if probability is yes and color is red, then it becomes 3 by 5. So 3 by 5 into probability of yes and SUV, so yes and SUV is become 1 by 5 into probability of domestic and yes, so then it become 2 by 5 into probability of yes, this is 5 by 10. So this is a 5 by 10. So at the after calculation, the answer is this 5 is already removed, 2 and 5. Okay, so after calculation, 3 divided by 5 divided by 5 divided by 5 divided by 5, then it become 0.024. Okay, now the next we'll find for probability no. We have to find that it is stolen is yes or no. The label we want is yes or no, so that's why we have to calculate for yes and no. So probability of X of no into no, so then it becomes probability of red no into probability of SUV no into probability of domestic and no into probability of no. So probability of red, stolen is no and color is red, then it becomes 2 by 5 into probability of stolen is no and type is SUV. So here no and type is SUV is equals to 3 by 5. So we'll write 3 by 5 into probability of domestic and no, then 3 by 5 into probability of no that we already calculated, which is 5 by 10. So we'll write 5 by 10 here. So after calculation, this is removed, 1.5. So after calculation, 3 into 3, 9 divided by 5 divided by 5 divided by 5. So then it becomes 0.072. Now the task is will compare the probability of no and probability of yes. So no, probability of yes is 0.024 and no is 0.072. So 0.072 is greater than 0.024. That is why if data sample if color equals to red, type equals to SUV, and origin is equals to domestic, then probability of stolen is no. So this is the answer, that based on the probability of yes and no, the probability of, so higher probability is become the answer. So here the higher probability is for no, so that is why the label is no. So that is how we can calculate the example using Navy based classifier. So, or we can classify our data with Navy based classifier. So that's it about it. Thank you so much for listening. Have a great day.